Welcome to the session number 6 from the playlist of properties of matter. The topic is the fractional change in the dimension due to the volumetric stress. And based on this topic, I have selected one question which was asked in the IIT-JEE main examination in the year 2018. So the question here is, a solid sphere of radius r made of a soft material of bulk modulus K is surrounded by a liquid in a container. A massless piston of area A floats on the surface of the liquid, covering the entire cross section of the container. When a mass M is placed on the surface of the piston to compress the liquid, the fractional decrement in the radius of the sphere is. Now decrement means the fractional decrease in the radius of the sphere is. So here we have been given 4 options and we have to find the correct one. So this question can be solved by using the formula of the bulk modulus. Now the bulk modulus is given by F V divided by the cross section area multiplied by delta V. Now here F is the restoring force, A is the cross sectional area, V is the original volume, and delta V is the change in the volume. Now bulk modulus is basically equal to the normal stress divided by the volumetric strain. So this is also equal to the volumetric stress divided by the volumetric strain. The volumetric stress in this case will be equal to F by A, and this is denoted by P. That is, P F upon A can be written as P, and delta V upon delta V can be written as delta V upon V. So here P is the volumetric stress and delta V upon V is the volumetric strain. So this can also be written as delta V upon V. Now here in this case, this volumetric stress, which is also called the pressure, will be equal to, see, when a mass M is placed on this massless piston, which is floating on the surface of the liquid, so the liquid will get compressed and the pressure, this P, or you can say the volumetric stress, will be equal to the mass M, that is M multiplied by G divided by the area of cross section. Now this is M into G upon A is the volumetric stress multiplied by delta V upon V. Now here delta V upon V is the volumetric strain. Now we also know that if there is a physical quantity, say X, and X is equal to A to the power, say P, and B to the power Q, then delta X upon X is equal to P delta A upon A plus Q delta B upon B. Now this is what we have learned in the chapter number 1 of the class 11 syllabus, that is the chapter of units and measurement. So in the chapter of units and measurement, we have learned that, and we have learned this formula under the topic of errors in measurement. So if X is equal to, this is a physical quantity, and this is equal to A to the power P multiplied by B to the power Q, then delta X upon X will be equal to P times delta A upon A plus Q times delta B upon B. So this is the formula which I will be now using here in order to solve this question. So the volume of the sphere, now here this is a solid sphere. Now the volume of the sphere is equal to 4 by 3 pi r cube. So delta V upon V will be equal to 3 times delta R upon R. Okay, by using this formula. If I use this formula or if I apply this formula in the volume of this solid sphere, then delta V upon V will be equal to 3 times delta L delta R upon R. So what I will be doing is I will be substituting the value of delta V upon V in this equation. Say this is equation number 1. Okay. So by substituting this value of delta V by V as 3 times delta R by R, I will be getting this formula as mg divided by A into, now delta V upon V is equal to 3 times delta R upon R. And this is the bulk modulus. And the bulk modulus in this question has been given as K. So K is equal to mg divided by 3 times of A in bracket delta R upon R. So now from this equation, we can simply find the value of delta R by R. So delta R upon R from this equation will be equal to mg divided by 3 times Ka. Now here delta R upon R is what? It is the fractional decrease or the fractional decrement in the radius of the sphere. So delta R upon R, which is the fractional decrement in the radius of the sphere, is equal to m into g divided by 3 times the bulk 3 Ka, where K is the bulk modulus of this solid sphere, and A is the cross sectional area of this massless piston. So the correct option here will be mg divided by 3 Ka. That is the third option. So the option C is correct. So in this question, the most important thing was that you have to utilize the formula of the bulk modulus, which is equal to the volumetric stress divided by the volumetric strain, and here volumetric stress is basically the pressure, which is equal to F upon A. So by using that formula, we were able to, and secondly, we have to also calculate the value of delta V upon V, which is and this value was calculated by using the this concept, that is, if there is a physical quantity x is equal to a to the power p, b to the power q, then delta x upon x will be equal to p times delta a upon a plus q times delta b upon b. So by using this concept, or you can say by using this relation, we had found the value of delta v upon v, which was equal to 3 times delta r upon r. And from this relation, we were able to find the fractional decrement in the radius of the sphere. So thank you very much for joining this session. In the next session, I will be now discussing about the work done in stretching a wire and the thermal stress and the thermal strain. So till then, have a nice day. Bye.